All right. Yeah, so those who are lying down on their bed and their laptops are on their table, please come to your laptops. We are starting. So I currently have five, six, seven. We have like 8 people in the class. All right. So for the sake of those who may not have joined us last week, and also for the sake of revision, I will go through what I saw Chi teaching. So from what I saw, he was taking you guys through creating a simple schematic with um, an Arduino Nano, which is this with 3 LEDs, which are these, and then there are resistors. And he also included a water level sensor, which are all connected to the Arduino Nano, right? So today we'll do the routing. Okay. But then to go over everything, so if for those who have no experience in Arduino, um, I would have to show you what an Arduino is, right? So these are Arduino boards. These are Arduino boards. They are simple microcontrollers which were made to help beginners in electronics to grasp the fundamentals. When you get to the hardcore electronics, you will understand why the Arduino was created. Hardcore electronics is hard, right? So the Arduino, we have the Uno, we have this is the Uno, right? The Nano is smaller. This is the Nano. This is the Nano that's smaller, okay. So the Arduino was created to like help beginners in electronics like start, all right, with the connections, the hardware connections and the software programming. Okay. So we have that in here. We have 3 LEDs and we have the resistors to connect the LED to the Arduino Nano, right? So what we did was that we went to the sorry, so in KiCad, I'm very used to the keyboard shortcuts. So I'll try my best to tell you the shortcuts I'm pressing, but for everything you can do with the keyboard, you can also do with the mouse. Well, almost everything. Um, so please excuse me, I have to get my laptop front. My PC has started heating. Okay, so I'm back. So the dialog I opened is this place symbols, all right? So for anything you want to place on the schematic editor, like the Arduino Nano or these LEDs or the resistors, you have to go to the place symbol. And the shortcut I pressed was A. You can see when I place my mouse there, there is in brackets A, telling you that that's the shortcut, all right? So you can either click on it or press A on your keyboard and this pops up. So when you go here, you search for Arduino, type in Arduino, and you can find Arduino Nano every. This is the board that my colleague used the last time. And he talked about footprints. This is its footprint. When we begin the PCB routing, you see this very footprint there. Okay. Then for LEDs, you went here, I believe, LED already placed. You can see under there already placed LED. If it wasn't placed, you'd have to look for it somewhere. LED, then resistor already placed, but the symbol itself is here. And the last component he used was a connector. Let me verify. Here, he used a female connector. So for that one, you press on. Yeah, connector. So I think he went with this 1x3 socket. Socket means it's a female, you plug something inside. Pin is like the pin, the middle ones. Okay. I hope the recap was able to get to everyone.
No, not really. Those that we weren't on last week. I think for myself, I'm finding difficulties in catching up.
And please, who was that who said he had difficulty catching up?
This is T plus. We joined within this week, so we couldn't get last week's session.
Um, okay, so I think last week's session, I don't know if it was recorded, but I will ask Chief. But so actually, what we are doing for the first 2 weeks, right, is just like a walkthrough. Don't worry if you don't understand everything. So Jay is just supposed to take you through the theory. He did that last week, and then he was supposed to just like brush through doing a simple circuit. Next week, I'm going to continue, but I'll start all over them with the schematic design. We'll do that for 2 weeks. Then Lemon will take you through the PCB routing and everything for the next, like, after my 2 weeks, here's 2 weeks, okay. So this is just like a complete walkthrough to help you see that this is where we start from, this is where we get to, and this is how we end, okay. So don't worry about that. We will start with the schematics all over. And I would assume that we all like understood what we were doing. Okay. So these are just symbols, all right. For the actual PCB, how it would look, um, it's not going to look like this. Okay. So okay. So when you are done placing all your symbols, the next thing you want to do is that you want to go here to annotate schematic. Okay. What annotate schematic does is that it gives numbers to every piece of symbol you've placed there. So you can see the resistor has R1, R2, R3. LED is D1, D2, D3. It could be possible that in your placement, some didn't get numbers. From what I can see, I think everything has numbers. The connector has J1, the Arduino has A1, and the rest have their numbers. But if you are working with a bigger schematic and you can't check through everything, you would have to do the annotation all over. So you can just come to here, clear annotation. Okay. So scope is supposed to be entire schematic options. So let me clear annotation. So you can see that all the numbers are gone because I've cleared all the annotations. Then you would click annotate. For order, this shows the order is going to number stuff, all right? So if you would choose this, it's going to start from the top, annotate down, then come up, go again. If you click this, it will go in the horizontal direction. I don't think that really matters unless you are, unless you have a way you want things numbered, all right? So for me, I'll just go with this and The rest are all right. So I'll just click annotate and close, and everything is just back to normal. So resistors are R1, 2, 3, LEDs D1, D2, D3. All right, the next thing you want to do is electrical rules checker. So the electrical rules checker checks your schematic and makes sure that nothing is wrong. You haven't done any wrong connections or everything is connected. All right. So when you open it, it's like this. You click run ERC and we have zero errors, zero warnings. Errors are things that you cannot live with. Errors like mistakes you cannot like just brush off. Warnings, sometimes you can brush them off from experience. There are warnings I've gotten and I'm like, yeah, I know I did this. I know what I was trying to do. Okay. So zero errors, zero warnings. I think that's actually good. And we close. The next thing is assign footprints. I think Che did all of those last week. He assigned every footprint. All of them are assigned. So the footprints are what you use to do the routing in the PCB. So let me just open the PCB and show you what we have. Wow. Because I'm recording for those who can't join, my GPU is really being used. My PC is heating. And I want to know if you guys can hear the noise from my PC. Like my fan is really making noise. Can you guys hear it? Vicentia, class perfect. Hello guys. I want to know if you guys can
No, yeah, no, there's no noise.
can't hear like a fan noise, nothing like
No,
that.
we can hear you.
Okay, sure, then I think that's okay. Right. I was worried that it would make noise. Okay, so let's continue then. So the way I got here was that over here I clicked switch to PCB editor. Okay, when you click that, this pops up. Over here is where you do your routing. Um, that's the second half of the headache in PCB design. The first half is the schematic. If you are using complex parts, you have to read data sheets, see how you do your connections and stuff. The second half is the routing. So currently we have nothing here. Um, over here, 3D viewer is how your PCB would look in real life. We have nothing currently, just this box. Okay. So the way we get our stuff from the schematic to the PCB is by clicking update PCB from schematic. All right, update PCB from schematic. Whenever you do changes in your schematic, it's not automatically updated in the PCB. You have to do it manually. So you click this symbol and then this comes up. All right, so for starters, you don't have to worry about these options. It is when you are making changes that you have to like select these options. So really relink footprints to schematic symbols based on their reference designators. So say before I did the annotate schematic, I had placed my symbols here, and then I go and change some numbers for the symbols, right? You will have to check this, else your symbols on the PCB will not be updated. All right. Um, this is something I'm sure Lemon will take you through, but for now, I think you should have this checked. Delete footprints with no symbols. Don't check this if you are not sure. Replace footprints with those specified in schematic. Check this and delete plus. Don't check this. So I think this is all right. So you can see zero errors, zero warnings, and you update your PCB close. So when you do that, you would have this You just click and it's placed. All right. Okay, so as you guys can see, this is the Arduino Nano. This is the LEDs. These three are the LEDs. This is the connector for the water level sensor, and these are the resistors. Okay, let's see how that looks like right now in our 3D viewer. So this is how it looks like. For those who are following with me, you would have a different color. I like the black soda mask and yellow outline. And let me just change that quickly actually. Okay, this is how your PCB should look like now. What I did was to change the color of the soda mask. Maybe you guys don't know what that is, but that's just the green covering on the PCBs. For those of you who have open phones and calculators, you see that the PCBs are either green. I think for laptops they are blue. And we have other colors. So I decided to change mine, right? Okay. So let's get back to the routing. All right. So in your PCB, let me. All right. So this is everything. Okay. So you want to begin routing. What's the first thing you do? The first thing I recommend you do before you start routing is that you place the components close to where they're supposed to be routed. What do I mean by that? So back to the schematic. Back to the schematic, we can see that this LED is connected to this resistor, and this resistor is connected to LED red. That is this part of the microcontroller. All right. So ideally, you would want to have this resistor close to this LED, and the LED and resistor close to the pin at which it connects to. Okay, so how would you do that? So if you come to the PCB editor, you see that there are some light blue lines that connect the terminals to where they're supposed to be connected. So if I were to bring this LED here, I can see that this part is coming to this resistor. All right. So you can either click and drag. As I said, I very much like the keyboard shortcut. So what I'm doing is that I'm using left mouse button to drag this around, click and hold and drag it around. And for those of you who are using a mouse, you press your scroll wheel, that's the middle mouse button, to drag the page around. For those of you who are not using a mouse, you are going to struggle with this because you would have to zoom in and zoom out. So you place your mouse here and then you zoom in. You can't drag with your touchpad. So you have to zoom in and zoom out. So I recommend that from here on going, if you can, please get a mouse because it will really make your life easy. Okay, so the keyboard shortcut I'll use now is I'll click here, press M. M means move, and I can move this around. Okay, so I'll place this here. Then the grid, the grids, all right. So for some of you, as you are moving your resistor around, you can see that it's not moving as finely as mine is moving. Let me show you what that looks like. So I'm going to change this to 1 mm. You click on this and it's moving like, see how it's moving, right? Okay, that's because your grid size is at a larger value. That is 1 mm. So this is allowed to move only 1 millimeter per drag. All right, but I'm using, I think, 0.1 mm, and I can move it more finely. You get it? So if you are struggling to move it to align, you can try reducing your grid size. Yeah. So I'm going to put this here quite close, very, not too close, something like this. All right, then I'm going to move this one to here, and I'll move this to here. Then I'll bring the rest. So I'll select them, press and bring them here. Then individually, I'll put them where they are supposed to be. I think this looks better. All right. For the water level sensor, that's the last thing we'll do. Okay. So now we want this to be close to where they connect to on the Arduino Nano Every. With very simple schematics, you can easily do this, but with more complex schematics, there are times where you can't really get your way around placing them close to where they are supposed to be. All right, and we would get into that, how to route effectively, right? So in order not to make routing a headache for you, you want things to be close to where they are. All right. So I think this guy is supposed to connect here. So I would select this, and the keyboard shortcut I'll use is repeat R. Okay, so I'll select these two and press R and press M. So you can see that this is close to where it's supposed to be. Okay, the same for this. So let me, I press Ctrl Z to move it back because the middle one has to be actually close to its place first. So R, sorry. Wait, let me pause here to ask the class if we all understand what I've done, or should I go over from somewhere? Perhaps I'm moving too fast, or I think you guys are getting it smoothly, but if you aren't, please let me know so that I go over it again. Okay, so Aaron says it's fine. Um, is Aaron speaking for the whole class or someone else has a problem? Okay, so I think it's okay for everyone. So this connects here, this connects here, this, sorry, this connects here. Let me repeat this one too. Yeah, so they all connect to the three over here. You can see lead red, lead green, lead blue. Okay, so I'll first place the middle one quite close, something like this. Okay, then this, I'll also bring this one way here, and then this one, I'll bring it here. So now you can see that, yeah, so I just turned off the ground rust nets. At appearance, if you go to nets, you can see all the connections here. So for 5 volts, if I click this, you see its net goes off. All right. So I'll turn off 5 volts and I'll turn off ground because those are like the last things we'll do. All right. Now the schematic is like clearer now. So we can focus on the other parts and forget about the power supply for now. Okay. So you can see that this is close to where it's supposed to be routed. So if I should start routing like this, I can easily route. So don't worry, we'll go through the routing. So you can see no route cross except for if this one was somewhere here, right? Then when I route this and it's time to route this, I can't cross here because these two have to connect. So I would have to find somewhere and connect this. Then your routing is all over the place, you get it. So we don't want things to be like that, all right? Is that there. And then lastly, we have the water level sensor. So we will place this here. Excuse me to turn off F5. Of you following, another tip I'll give you is that you should turn off this f.fab. You can see when I turn it on, there are these writings on the board. Um, when the board is produced, these things will not be written on it. So in order to like help you focus on what you are doing, just turn it off. All right, both F-fab and B-fab if you have stuff under your board. But if you just place things on the front layer, you can just turn off the F-fab. For things like silk screen, which is F silk screen, B silk screen, those would be printed on the board. Okay, so you would want to like place them correctly. Let me turn on 5 volts and ground again. I believe we can start routing. So to route, you have your toolbar here. There are a lot of tools here. The one for routing is this route single track, and the keyboard shortcut is X. Okay, so you either click here, you come here, and you click and route, or you can come here, press X, and then draw your route. So all of these have been routed. And then I have to connect the resistors to the LEDs. Resistors to LEDs. See how simple it is because we place them close together. Let me flip this. Yeah. Sometimes your route will be close to other components. You can simply click and drag it. But then as you are dragging, you see this thing happening over here. Okay. So what I'll do is that I'll start routing. I'll come here, click, then I'll come here. Okay. So sometimes when you let's say, let me undo that. So what I did first of all, I just clicked and I drew it here and I clicked. But the disadvantage with that is that you have things like this. You have your track being too close to another component. All right. So what you want to do is that as you're routing, you'll be clicking where you want the track to stay at. So over here, if I click, this part doesn't move again. So it's just the head that moves. So now I can click here and I'm done. Okay, so you guys just have to play with the software and see how it is. And all of these things, I mean, there are some things that are not really to be taught. It's you that when you're playing around and you're figuring things out, you realize that you can do this, you can do that, all right? So don't worry. This whole training is just to get you started. As you guys build your own circuits and PCBs, you would realize even things that I may not have realized. Okay. So for the ground, routes here, routes here. Okay. I think this looks good. Now it's left with the 5 volts. This one, okay. Come here. This route I just did isn't good at all. It isn't. And you see over here, we have this weird V shape. It's not recommended in PCB design. And over here, we have this 90-degree turn. In PCB design, as much as you can, you don't want your tracks to bend at 90 degrees. At most 45 degrees like this, but never at 90 degrees. It has something to do with the EMI, the electromagnetic interference and stuff. With a simple board like this wouldn't really matter. But as you are building more complex stuff, it would matter. So you want to get used to doing just 45-degree turns, even with simple PCBs. So that when you're moving to the more advanced stuff, it's like it feels before you've been doing it, and it's no headache when you're routing complex PCBs. Okay, so I click Ctrl Z to undo that. And let me try from the top here. Get here. I keep doing this. So let me press escape. Escape, click this, delete this. Then let me come and start from here. Yeah. So as you guys noticed, you can start routing and get here. When you get here, you just hit escape. Something like this. Routing, yes, click and hit escape. You have your track here. Then maybe let's say it was supposed to be connected to here. You can now come here and then. So because those two are not connected, it's not joining. But if it's supposed to be connected, it would just snap onto it. Okay. So that's just helpful to know. And lastly, we have to connect this guy to this side. So we would have to pass the back. So click this one too. So what I can do is that I'll just click here. So as I said, no 90-degree bends. So I'll rather click here and then bend it like this. All right. Yeah. So we are done routing. How do we know? All the rust nets are gone. The blue, thin blue stuff, they are all gone. That's how you know you are done routing. Okay. And lastly, you want to draw a board outline. You want to draw a board outline. When you come to the 3D view, you can see there's a warning here. Board outline is missing or malformed. What that means is that you have not drawn the shape of your PCB. It looks like this in a 3D viewer. That's because it drew an outline around your components, but you yourself, you haven't drawn an outline. So if I were to draw an outline, the outline is edge cuts, all right? Here in layers, you see a lot of stuff. It looks overwhelming at first, but I'll just explain the simple ones, the ones you need to know. So FCU is the front of the board. So if you can see, its color is red and our traces colors are red. So all the routing we've done is on the front of the board. This is a 2-layer board we are doing. For multiple layer boards, you see more layers, maybe ground.cu with other colors. But for this one, we're able to do routing on one layer. Okay, so this is FCU. BCU will be the back. We have done no routing on the back, so this board can easily be manufactured. F adhesive, B adhesive. Honestly, I don't know. I really don't know. F paste, B paste. These ones will show when you are using SMD components. SMD components are the components that are flat on your board. They don't go through holes. In a 3D viewer, you can see that every component passes through the front to the back. The Arduino Nano has holes in here. The LEDs, the connectors, everything here we are using. So if you come here, through hole models, if you click this, they are all gone, meaning that everything is a true hole component. SMDs, nothing is going, meaning that there are no SMD components. All right. So when you are using SMD components, this will be relevant. I'll not explain that right now. F silk screen are the writings on the board. So you click this, they are gone. FCU2, you click it, the routings are gone. B silk screen will be if you place stuff at the other side of the board. All right. So F silk screen for the front here, B silk screen, B for the back. F mask, B mask. That's the solder mask. In the 3D model, the solder mask is this green covering all over the board. At the parts where you have copper connections, where you do soldering, the solder mask allows an opening, but things like traces. So your solder mask would cover your traces, your routings to protect it. And the place where you're supposed to solder your components, like let's say here around here, it's exposed. All right. So that's the solder mask here. I think we can hide it and hide it over here. So you see it's hidden and it's showing. All right. The rest of the stuff, F fab, B fab, as I said, you can hide these. And these are not really needed. F courtyard are the bounding boxes around the components. You don't really have to learn all of this. It's this kind of skill is a learn as you go skill. All right, you don't really have to know about all of this. Myself, I don't know the use of these ones, user 1 to 4, because I've not reached the stage where I have to use them. When I have to use them, that's when I'm going to learn about it. But for just the basics, is the routing and then your board outline, the shape of your board. So the layer for that is edge cuts. See, board perimeter definition, when you mount over it, edge cuts, select that, and then you use one of these shapes to draw your board outline. So let's say you want your board to be circular, right? You click on this, you click somewhere here, and then you draw the circle for your board to be inside. Now I've drawn this circle around it. If you click on it and you come down here, you can see that the layer is edge cuts. You go to your 3D model and you have a circular PCB. That arrow at the top is gone. You have your PCB, a circular PCB. And unless this is how you are supposed to design your PCB to fit in something like a watch or in anything at all, unless it has to fit in something like that, I don't see the use of using a circle. You'd want it to be as small as possible. All right. So I'm going to undo, and I'm going to go with a rectangular shape. So I'll draw somewhere from here. Yes, another tip I want to give you. So you guys can see that I have this crosshairs, the crosses around where my mouse is moving. I think for some of you, this is not on. So what you want to do is go to preferences, go to PCB editor. Let me see, cursor, always show crosshairs, and then take full window crosshairs. For the footprint editor, it would have been the same, show crosshairs. It would help you with, let's say I want to draw this box, okay? the crosshairs will show me where I should start from. So if I were to start from here, I will know that the trace I've done here, if I click here, you can see that the routing I've done here, um, it's not going to be included. You get it? You can see over here. All right. So the crosshair helps you to draw things well. So I should start from here the trace is where this trace is at this side and this silk screen is under it. You get it? And I don't really know how to explain it, but I think for those of you who have enabled it, you should have live easy now. You should have live easy now. This is the PCB size I'll use. You click on this. It says that the width is 337 millimeters. That's 3.7 mm by 49.7 mm. And I think this is okay. You go to your 3D model. This is your PCB. Who are following, I will give you 5 minutes to finish before I continue, and then I'll take some questions. After that, we'll continue. Go ahead. Hello. Are all done. I want to believe that we are all done. I believe you should have something like this now. As I said, all of this was all of this was just a walkthrough from start to finish. Okay. For the next 4 weeks, we will get deep into things. We will not be doing this. Okay. So right now, I want to take any questions or any comments, whatever you guys have for me. Any questions, any comments? Yeah, so one more thing for those of you who don't know what a data sheet is, let me quickly show you one. Let me quickly show you. People have heard about ESP32. ESP32, this is their site. This is their site. Everything you need is here, expressive.com. So you go to hardware, you come to modules. They have the SOCs, modules, dev kits. Let me just show you what they are. So the SOCs are the chips itself. They're very small chip, which you would struggle to use at first. That is why they do modules. So these are the modules. And then the modules are used on boards. So something like this, ESP32, S3 dev kit. Some of you have seen boards like this with the module on it, and inside the module is the SOC. Okay, so module. So ESP33 S3 room 1 is currently my favorite. So you click here, the data sheet should open here. This is 52 pages and it's filled with valuable information that helps you to connect or to use the ESP32 module in any circuit. the front page, they tell you that this data sheet is for the room 1 and 1U. The 1U is this one and the one is this one. The only difference between these two is that the one has an antenna. Let me scroll in. So the one has an onboard antenna over here on the PCB. All right, and then the 1U doesn't have an antenna. Rather, it has a U.FL connector, which you should connect an antenna to. So like, yeah. So this is the Wi-Fi connector. This is the antenna, and this end is what should connect over here. Okay, that's because this board has onboard Wi-Fi, as you saw over here. That's the first thing. 2.4 gigahertz Wi-Fi and Bluetooth. Okay, yeah. They will tell you everything about it. The data sheet contains everything to know about the module. Then the contents, module overview, block diagram, pin definitions. But the one important part is module schematics. I think it's this. This. And it's this peripheral schematics. This shows you a sort of default connection. When you buy the module, what's the best way or what's a starting way to connect it? Most data sheets have this, will really help you. So they show you the connections. 1x4 connector for UART, 1x4 connector for, I think this is JTAG. Then this over here for the boot option, a button to reset the board, then USB connection. Okay, I know this looks a bit complex, but yeah, most data sheets have this. Let me show you another data sheet. Let me see. Let's I check one of my projects. Let's I check one of my projects. Okay, so this is a voltage regulator. Description is a low noise LDO. LDO means linear dropout regulator. Linear dropout regulator, yeah. That can supply up to 250 mA output current. Okay, so you want to use a voltage regulator. You don't have to read the data sheet as I told you guys last 2 weeks Saturday. You don't have to read everything. But the more you advance, the more things you'll be looking for in your data sheets. The best thing to do is to come to 7, application and implementation. Application and implementation, and this shows you a typical application. So this is how the thing looks like in the schematic. It has input. Input is the, maybe you have 9 volts coming, you have 9 volts and you want to bring it down to 3.3. Okay, this is what you use. So input here will be 9 volts, output you get 3.3. Enable pin is to turn the regulator on or off, and we have ground. So they just say that you should use a 1 UF capacitor on the input and one UF capacitor on the output. And that is it. That's it. And over here to design parameters, they tell you that input voltage range is 2.2 volt to 5.5 volts. So that means that I can't use this for my 9 volt supply. I would have to use a different regulator. But if I have, say, 5 volts, I can use this. And then this shows how the regulator would look like on the PCB. They have two types. They have one that would look like this and one that would look like this. Usually you go with this because it will be easier to solder than something like this. Then you have your pin functions. They tell you what each pin is supposed to do, the function. Then you have your absolute maximum ratings. And it's filled with important information required to help you connect the regulator. Okay. So now I'll pause for any questions that you guys might have for me right now. If you have a question, you can unmute and ask. If no questions, we'll be ending the class in like 5 minutes. Yeah. Hmm. I think there are no questions. So the last thing I want to show you, I think it would be fair to show you. I recently posted the 3D view of a PCB design I did. I think it would be fair to show you how the routing looks like. So let me just open that. Yeah. So this is the schematic. This is the main IC. I have this. It's called. This is the name. Yeah, it's a sensor IC, and then I have my connectors here. I have push buttons here, and I have things around. So in this project, I'm using 3 schematic pages. You come to the right, you can see that I have root page and I have comms. Comms are just the stuff that will be sending information wirelessly. So I have an ESP32 here. This is the room 1U. I showed you the 1U earlier. This is the room 1U. I have things connected here. And then this is a LoRa module. Okay. And then the power. My regulators are here. I'm using 2 regulators because I have to provide power for both my digital section and my analog section separately. Okay, then I have my battery connector. This is for checking the battery voltage. Don't worry, the things look plenty, but see, the goal is that you want to break, like you have something you want to build, you want to break it into sections and focus on every section separately. So over here, I've put my power here. My system needs 2 kinds of power, DVDD and AVDD. So I put it here, I do every connection, and I use these flags to connect them so that when I need DVDD, maybe here, it's just here, AVDD is just here. All right, that's on the schematic. But when it comes to the PCB, and that's like, for me, that was 2/3 of my headache because things were connected everywhere and I had to do the connection manually. Okay, so this is just the schematic. Then how does the PCB itself look like? Um, yeah, so this is how the PCB looks like. You remember, this is the image I sent. Yeah, this is the image I sent. So this is the main IC. This IC, its pins are under it. Like come to the PCB, you can see that I have done the routings and they are all under the IC. So because of this, I had to use a 6-layer board. You come to my layers, you can see F, C, I have to rename this. It should be ground 1.c, but I have 1, 2, 3, 4, 5, 6 layers. So this is how everything looks like. So don't worry, you guys, we will go through all of this. By the time we are done, you will be able to do, you should, okay, with some practice, yes, you should be able to easily do something like this. Okay. So there are no questions, and that's all for today. So I guess I'll end the meeting now. So all the best to you guys. And we give you some YouTube resources to check out. The one I'll recommend, top of my list, is Phil's Lab. And for every good PCB I've been able to do is this guy, Phil's Lab, that has really helped me. Yeah, so Phil's Lab, this is his channel. He has everything related to PCBs. You can see over here. He does quite complex stuff, so you just have to start with something that is a bit okay. So he takes you through silk screen and soda masking, video number 133. Yeah, BGA PCB design tips. So for that IC I was using, it's called a BGA, ball grid array IC. I came to this video to know how to route it. I watched it and I was able to do it. Okay, then we have 32 firm ESP32 firmware tutorial. And this is a tutorial for programming ESP32s. I also watched this video for my board. He has a lot of videos, so you guys can start over here. If it's too complex, you can find another good channel, start there, and then when you're ready, you can come here. All right. So all the best to you guys. We meet you next week. Bye.